All right. This particular section is about classical probability and A union B and independence. So events D and E are independent. And the probability of D is 0.6 and the probability of D and E is 0.18. So please remember a couple things. That's the intersection sign, and when they say and, they're saying 0.18. They're also telling me that because it's independent, the probability of D and E equals the probability of D times the probability of E. Now that's only true if they're independent. But since they're independent, we know that we can do that. So this ends up being 0.18 equals 0.6 times E. Well, if I wanted to solve for E, I could divide both sides by 0.6. And I find out that E equals 0.3. Okay, so it's obviously not that. We just found out that it was 0.3, so we know it's not A. So now I see the word or. Or tells me that I'm working with this formula. The probability of A union B equals the probability of A plus B minus the intersection. Only in this case, we're working with D and E. So the probability of D and E, D union E, because that's my or symbol. That's supposed to be the U, equals the probability of D plus the probability of E minus the intersection. So I'm plugging in, and I don't have this yet. That's what I'm looking for. But I know D is 0.6. I know that E is 0.3. And I know that the intersection is 0.18. And when I find out that the probability of D union E equals 0.72. Each person in a random sample of adults indicated his or her favorite color. The results shown in the table below are reported by age group of the respondents. If color choice is independent, when they say if, they're saying pretend. If it's independent of age group, which of the following expressions is equal to the expected number of respondents who are aged 30 to 50 inclusive and prefer green? So we want green. And independent of age group, which is the 30 to 50. So we want, those are our two groups. Now there's a couple ways to go through this. I'm going to give you the long way initially, then I'm going to show you the shortcut. The long way is to go, you know what? They want independent. If independent, the probability of A and B equals the probability of A times the probability of B. So in this case, the probability of green is 99 over 314. That's the probability. And the probability of B is 108 over 314. But they want the expected value. Well, this is a probability. Expected value is n times the probability. Well, we have our probability and our n is this. So that would be 314 in front. Well, that cancels off one of those. So now we have 99 over 108 divided by 314, which gives us A. That's the long way. The short way is row total times column total divided by total. 99 times 108 divided by 314. And that will help you out with chi-squared. All right. It also helps you out with independence, but it'll also help you out with chi-squared. Okay, so I had the question, when would I want to do 35 divided by 314? That's asking the probability of A and B, and the probability of A and B is 35 divided by 314. And I would use that if they just said, hey, what's the probability of getting green and or probability of that intersection? So if they asked me for that, that's what I'd record. But here they qualified it and they said, hey, if it's independent, what would you do? Well, if it were independent, it's not going to be 35. It's going to be some value different than 35. In fact, because it's not independent. If it were independent, that would work. But since it's not, we have to find what independent would be. So 99 times 108 divided by 314 is 34. So it's close, but it's not right. So 34.05 would be what it would need to be if it were actually independent. All right, so this one's actually in our note spiral, and it's a very important problem. So a simple random sample of adults living in a suburb of a large city was selected. The age and annual income of each adult in the sample was recorded. The resulting data are summarized in the table below. Great. So the first part, what is the probability that a person chosen at random from this sample will be in the 31 to 45 category? Okay, 31 to 45. Believe it or not, all I needed to do was go 89 over 207. And that would be full credit. And that actually got me a point right there. Now, I like to convert it into a decimal, but really, if I just left it as a fraction, that's fine. I do have to show the fraction. Part B, what's the probability of a person chosen at random from the sample whose incomes are over 50,000 will be in the 34 to 45 category? It says, so let's read that slowly. What is the probability that a person chosen at random from those in the sample whose incomes are over 50,000? It's like, oh, all we care about is the over 50,000. So that's the group we're looking at. So that's going to give me my denominator. So that's my denominator, and we want the 31 to 45. So what we have essentially is an intersection over given. And I would generally write the intersection over given out. But all I have to show as far as my work, I don't have to show all this nasty stuff. I could, because technically that's 35 over 270, and that's 96 over 270. But really all I have to show is, oh, my given was this group of 50, so I can put 96 here, and I can put 35 on top, and I end up with 35 over 96, and that would be full credit. And if I take 35 divided by 96, I get that 0.365 number that I list right there. Okay, so the nice thing about that is we should be able to get those 2 points fairly easily. The next one's a little more challenging, although I think it's very easy to get partial. To get full depends. So it says, based on your answers in part A and B, is annual income independent of age category for those in the sample? Well, we need to know a formula, or know that a formula exists on the formula chart. Here's the formula that exists on the formula chart. The probability of A given B over the probability of A equals the probability of B. Actually, I'm sorry, I wrote the wrong thing. The probability of A given B equals the probability of A and B over the probability of B. Well, that's what we were working with. That's what we just found in the first part. Probability of A given B equals probability A and B. Well, that's the 35 over 96. However, there's a special thing. If it's independent, the probability of A and B over the probability of B equals the probability of A. Well, we just found A. A was up here at 0.43. This is 0.365. So all I had to do was say, oh, this is true if independent. So if independent, that's true. And I go, okay, and at 0.43 does not equal 0.365. Therefore, they're not independent. Now, I'll be honest with you. I think that's hard for students. So that would get you full credit, but I could get you partial, which would get you 3 points. Partial is pretty easy because we should know the independence rule that says the probability of A times the probability of B equals the probability of A and B. Well, all we care about are over 50. Here, I can do this a little better, I think. Yeah, that'll work better. All we care about is over 50, and we care about the 31 to 45 category. So 96 over 207 times 89 over 207 needs to equal 35 over 207. So let's try it out. 96 over 207 times 89 over 207 needs to equal the 35 over the 207, the intersection, because that's my basic independence rule. Well, I don't know what those numbers are, but let's try it out and see what happens. 96 times 89 divided by 207 squared gives me 0.1993. And then I take 35 divided by 207, and I get 0.1690. They're not equal. So because they're not equal, they are not independent. And you have to make the statement, because they're not equal, they are not independent. All right, next section is going to be on sample space. I guess we have a handful of multiple choice questions. Oops, I need to pause this.